Hey everybody, this is Larry. Let's do today, day 25 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. And we have 1143, longest common subsequence. Okay, I don't really have much to say about it today. I don't know. I probably already have videos on this. And to be honest, this is a literal textbook poem. I mean that in that I think this is just like a very common thing to be in a textbook. It's one of those things that people use to teach dynamic programming in the beginning, and of course from that how to say this, the core part of it is still going to be the same. It is just trying to figure out how to how to create these overlapping subproblems, right? But yeah, I don't know. Maybe I'm just being a little bit lazy today. My apologies. My energy is kind of tired. I actually end up walking like 20 miles or something after I did squats at the gym. So I don't know. Why did I do that? I don't know. I am not a smart man. But yeah, I don't really have much to say about this one. I think the idea, if you haven't done this in a while, I would definitely say, do dynamic programming, memoization. Try to do it all through the entire progression, right? Even if you get it right, try to do it every step of the way. And what I mean by that is, like I said, top-down dynamic programming or memoization, bottoms-up or tabulation, and then the space optimization so that it is only over n time or whatever it is, right? You could say n plus m or something, but yeah, something like that. Oh, sorry, and space. Sorry, optimization on the space, not the, but that's pretty much the idea. I think there is also like a crazy way to do it, but yeah, I'm gonna do this top down just because I think it's easier to understand, because it just becomes a way to, in a way, brute force. And for me, not all problems, but for a lot of problems, top down is actually, it's just slightly easier in the sense that you don't have to worry about the ordering, right? Because basically, when you need something, you go and get it. That's basically top down. And the way that I think about bottom up is, when you process something, you already have everything you need, right? So they're kind of very similar, but I don't know. Some people are better at some, and some people are better than the other, and some problems are just more suited for some of these, right? So definitely use the one that you're more comfortable with. But if you have one that's comfortable with and you already solved this, then try to do it the other ways, just to kind of squeeze in the little web, squeeze in a little bit more practice, even on problems that you are familiar with. But basically the idea for the brute force is, of course, just processing the suffix one character at a time. So, and a shorthand for that, sometimes I really go into it today, maybe not so much, is just using index 1, index 2, because the index represents the suffix of the string, right? So basically we have to get the LCS, the longest common subsequence of text 1 starting from the suffix, and text 2 is also starting from the suffix, right? And of course, if n1 is equal, if index 1 is equal to n1, then we return 0 because we ran out of string. Also, or I guess index 2 is equal to n2, then we also return of 0, right? Because we ran out of string. Otherwise, then now, given text 1 or text 2, then we can say either the longest common subsequence is going to come from the next character of text 1, or it's going to come from text 2, or if they're equal, then we can try to use that instead, right? So basically you have three cases, or max, I guess, right? You have get longest index 1 plus 1, index 2, get longest index 1, index 2 plus 1, or, well, I guess just do this for now. And then if text 1 of index 1 is equal to text 2 of index 2, then we can also do something like get longest index 1 plus 1, you consume 1 character, and then plus 1 for having one character that's the same, right? So then now return longest, and that's pretty much it. You start from 0 prefix, and of course we do this dance about oops, how did I forget a comma? That's silly. You know, this may time out, didn't actually time out here, but yeah, this is going to time out because you literally do 3 recursion, well, maybe 2 recursions, but many times also 3 recursion. So the thing to notice is that these prompts are overlapping, right? So index 1, oops, go away please. Index 1 can go from 0 to n1, index 2 can go from 0 to n2, and so we memorize it that way. So this is the way that I do these on things. I get comment on it every time for some reason, but yeah, and the reason why, you know, it's just easier. Ooh, I was gonna say easier, but then I made a typo anyway. It's just easier to kind of read this and go, if you have cache of index 1, index 2, then we can just return the already cache, right? And then at the end, we set the cache to longest and also set it to having that cache. And that should be good. Hopefully I didn't miss like an edge case. Yeah. Apparently I have done this from, well, I guess these 3 are overlapping. Maybe I did the progression here. I think I did the progression on, I do have a video, by the way, on dynamic programming and progression, so definitely check that out if you're curious about changing to the other ones. But yeah, this is going to be n1 times n2 time, and also n1 times n2 space, so quadratic. But as I said, you have to I forgot what I was gonna say. Never mind. Man, I am just tired today. Need some sleep. So I'm recording this a little bit later in the day. It's 1:20 a.m. and I'm old. I need sleep. So yeah, that's all I have for this one, though. Let me know what you think, and yeah, stay good, stay healthy, to good mental health. Enjoy the rest of the week. I'll see y'all later and take care. Bye bye.